A water park hires students for the summer. The students' hourly wages are shown in the table. Part A. Find the mean, median, and mode of the hourly wages. First find the mean. The mean x-bar is given by the sum of the wages shown in the table divided by the number of wages, 8, which equals 9 35/100ths. Next find the median. First order the data in numerical order. Because there is an even number of values, the median is the mean of the two middle values, 8 50/100ths and 8 70/100ths. The mean of these two numbers is given by the quantity 8 50/100ths plus 8 70/100ths divided by 2, or 17 20/100ths divided by 2, which equals 8 60/100ths. Next find the mode. With the data in numerical order, you can see that 8 50/100ths occurs most often. So the mean is $9.35, the median is $8.60, and the mode is $8.50. Part B. Which measure of center best represents the data? Explain. Both the median and the mode represent the data well. The mean is greater than most of the data. A water park hires students for the summer. The students' hourly wages are shown in the table. Part A. Identify the outlier. How does the outlier affect the mean, median, and mode? The value $14.50 is much greater than the other wages. It is the outlier. First find the mean, median, and mode of the data with the outlier. You can find that the mean is $9.35, the median is $8.60, and the mode is $8.50. Then find the mean, median, and mode of the data without the outlier. First find the mean. The mean x-bar is given by the sum of the values shown in the table except the outlier divided by 7, which equals 8 61/100ths. Next find the median of the data without the outlier. First order all of the data except the outlier in numerical order. The median is the middle value, or 8 50/100ths. Next find the mode of the data except the outlier. With all of the data ordered in numerical order except the outlier, you can see that 8 50/100ths occurs most often, so the mode is 8 50/100ths. So when you remove the outlier, the mean decreases $9.35 minus $8.61, or 74 cents. The median decreases $8.60 minus $8.50, or 10 cents, and the mode is the same. Part B. Describe one possible explanation for the outlier. The outlier could be a more experienced student who was given greater responsibilities, while the other students could be new and inexperienced employees. Two game shows select 12 contestants each. The ages of the contestants are shown in the tables. Find the range of the ages for each show. Compare your results. First, find the range of the ages for show A. Order the ages in numerical order. The range of a dataset is the difference of the greatest value and the least value, so the range is 52 minus 19, or 33 years. Next, find the range of the ages for show B. Arrange the ages in numerical order. The range of the dataset is the difference of the greatest value and the least value, so the range is 40 minus 20, or 20 years. So the range of ages for show A is 33 years, and the range of ages for show B is 20 years. So the ages for show A are more spread out. A game show selects 12 contestants. The ages of the contestants are shown in the table. Find the standard deviation of the ages. Use a table to organize your work. Interpret your result. Let the ages be given by different values of x. First, make a table. Then find the mean x bar. The mean of the ages is given by the sum of the ages divided by the number of ages, which is 12. So the mean x bar equals 384 divided by 12, or 32. Use 32 for x bar in the table. Next, find the deviation of each data value, x minus x bar. When x equals 35, the deviation x minus x bar equals 35 minus 32, or 3. When x equals 52, the deviation x minus x bar equals 52 minus 32, or 20. When x equals 32, the deviation x minus x bar equals 32 minus 32, or 0. Continue to find the deviation for each data value. Next, square each deviation, the quantity x minus x bar squared. When the quantity x minus x bar is 3, the quantity x minus x bar squared is 9. When the quantity x minus x bar is 20, the quantity x minus x bar squared is 400. And when the quantity x minus x bar equals 0, the quantity x minus x bar squared is 0. Then continue to square each deviation. Next, find the mean of the squared deviations, or variance. The variance is given by the sum of the squared deviations divided by the number of terms. Because the sum of the squared deviations is 1096 and there are 12 terms, the variance is 1096 divided by 12, or approximately 91 3/10. Next, use a calculator to take the square root of the variance. Because the variance is 1096 divided by 12, the square root of the variance is the square root of the quantity 1096 divided by 12, or approximately 9 6/10. So the standard deviation is about 9 6/10. This means that the typical age of a contestant on show A differs from the mean by about 9 6/10 years. A water park hires students for the summer. The students' hourly wages are shown in the table. Part A. Find the mean, median, mode, range, and standard deviation when each hourly wage increases by 50 cents. First find the mean, median, mode, range, and standard deviation of the original data set. Then add 50 cents to the mean, median, and mode. The range and standard deviation will be the same as the original range and standard deviation. First find the mean. The mean is given by the sum of the wages divided by the number of wages. Because the sum of the wages is 74 8/10 and there are 8 wages, the mean is 74 8/10 divided by 8, or $9.35. So the mean of the new data set is $9.35 plus 50 cents, which equals $9.85. Next find the median. Arrange the data values in numerical order. The median is the middle term. Notice that the two middle terms are 8 50 hundredths and 8 70 hundredths. So the median is the sum of the two middle terms divided by 2, which equals 17 20 hundredths divided by 2, or $8.60. So the median of the new data set is $8.60 plus 50 cents, which equals $9.10. Next find the mode. With the data arranged in numerical order, you can see that 8 50 hundredths occurs most often. So the mode is $8.50. So the mode of the new data set is $8.50 plus 50 cents, which equals $9. Next find the range. Notice that the least value is 8 15 hundredths and the greatest value is 14 50 hundredths. So the range is 14 50 hundredths minus 8 15 hundredths, which equals $6.35. Note that the range of the new dataset is the same as the range of the original dataset. Next find the standard deviation. Use a table to organize your work. Let the hourly wages be given by different values of x. Because the mean of the original dataset is $9.35, use 9 35 hundredths for x bar. Then find the deviation of each data value, x minus x bar. 8 15 hundredths minus 9 35 hundredths equals negative 1 2/10. 8 70 hundredths minus 9 35 hundredths equals negative 65 hundredths. 8 50 hundredths minus 9 35 hundredths equals negative 85 hundredths. 8 50 hundredths minus 9 35 hundredths equals negative 85 hundredths. 9 0 hundredths minus 9 35 hundredths equals negative 35 hundredths. 8 25 hundredths minus 9 35 hundredths equals negative 1 1/10. 14 50 hundredths minus 9 35 hundredths equals 5 15 hundredths. And 9 20 hundredths minus 9 35 hundredths is negative 15 hundredths. Next find the square of each deviation, the quantity x minus x bar squared. Negative 1 2/10 squared is 1 44 hundredths. Negative 65 hundredths squared is 4,225 10,000ths. Negative 85 hundredths squared is 7,225 10,000ths. Negative 85 hundredths squared is 7,225 10,000ths. Negative 35 hundredths squared is 1,225 10,000ths. Negative 1 1/10 squared is 1 21 hundredths. 5 15 hundredths squared is 26 5,225 10,000ths. And negative 15 hundredths squared is 225 10,000ths. Next find the mean of the squared deviations, or the variance. The variance is given by the sum of the squared deviations divided by the number of squared deviations. Because the sum of the squared deviations is 31 185 thousandths and the number of squared deviations is 8, the variance is given by 31 185 thousandths divided by 8, which is approximately 3 9/10. To find the standard deviation, take the square root of the variance. Because the variance is 31 and 185 thousandths divided by 8, the standard deviation equals the square root of the quantity 31 and 185 thousandths divided by 8, which is approximately $1.97. Note that the standard deviation of the new dataset is the same as the standard deviation of the original dataset. Part B. Find the mean, median, mode, range, and standard deviation when each hourly wage increases by 10%. Recall that the original dataset has a mean of $9.35, a median of $8.60, a mode of $8.50, a range of $6.35, and a standard deviation of $1.97. To find each value when each hourly wage increases by 10%, multiply the original mean, median, mode, range, and standard deviation by 1 1/10. So the mean is $9.35 times 1 1/10, which is approximately $10.29. The median is $8.60 times 1 1/10, which equals $9.46. The mode is $8.50 times 1 1/10, which equals $9.35. The range equals $6.35 times 1 1/10, which is approximately $6.99. And the standard deviation is $1.97 times 1 1/10, which is approximately $2.17.